All right, let's do a little bit more trigonometry. So I've got find the antiderivative of cosine squared x sine x dx. You're not going to fool me this time. I know exactly what part should be my u. How do I know that? Because I've already done a problem just like this. Yeah, so if cosine x is my u, taking its derivative, I have negative sine, and sine is part of that integral that's right there. So u is going to be equal to cosine x du negative sine x dx. I have to fix my negative sign, throw a negative there, compensate with a negative on the outside of it, and then rewrite stuff. So this will be rewritten as a negative integral of this negative sign with this sine x dx. All of that becomes your du. And cosine squared x, cosine is u, so cosine squared x is going to be just a u squared. That'll be equal to a negative u to the third power over 3 plus c. Rewrite stuff as a negative, maybe 1/3, cosine 3, cosine to the third, yeah, x plus c, and it's done. All right, now that has little to do with the next set of problems, but it is trigonometry, and it's going to lead us into having some more anti-differentiation rules for the different trigonometric functions. So let me just kind of refresh your memory here. So we have a rule for something like this. We have a rule for secant x tangent x dx, and that's equal to secant x plus c, right? But what if we just had secant by itself, not secant tangent? We had secant x dx, and I wanted to find its antiderivative. Well, that's the kind of thing that we're just about to do. So, on example 11, we have the antiderivative of secant squared x over tangent x with respect to x. Okay, so you might think, based on the other examples that we just did, that your u should be secant x, right? It might seem obvious u is equal to the secant of x. Oh, stop. Come on, fix that quick before somebody walks in. Secant of x. There we go. Whew, that's embarrassing. Okay. So secant of x as your u. If it was, then its derivative is secant tangent, which we're not going to be able to fix here because the tangent's on the bottom. Yeah? Okay. But hey, secant squared, isn't that the derivative of tangent? And tangent's already on the bottom here, so watch. Boop, go away. Let's get rid of this stuff. Bye, because that was wrong. Wanted to delete. There we go. So let's try u being equal to tangent, assuming that I can spell it correctly. All right. And then our du is going to be equal to secant squared x dx, which we have. So when I go to rewrite this integral, I have let's say the secant squared x dx, all of that is your du. And then the tangent that's on the bottom is your u. You have du over u. So think of it like this. Maybe if it's helpful, 1 over u du. What's the antiderivative of 1 over u? Well, this is one you can't use the power rule on. It is its own antiderivative. It's the natural log function. So this is equal to the natural log of, don't forget, absolute value of u plus c. And then backtrack here. Backtrack, and let's take out our u and replace it with tangent. There we go. That's equal to natural log of the absolute value of tangent x, boop, plus c. Voila. All right, let's try this one over here for tangent. Okay, so I did this to help us understand how we're going to do this tangent function right here. Okay, it's gonna kind of be the same thing. So this one is not an antiderivative rule that we have going on over here, because like, what, we're going to start with this? No, chances are not. But we might start with just tangent. Okay, so it's not obvious at all that you would do any kind of substitution on tangent because there's nothing here, right? You got tangent, you got the function, and that's it. But you could rewrite it. So remember back from pre-cal, one of the tips working with trigonometry is that you can always turn it back into sines and cosines. So sine x over cosine x dx. And you really don't have a composite function here either. But you do have something that's very similar to what happened over here, where if we let cosine be the u, its derivative is negative sine, which is what we have up top. So our u is going to be equal to cosine x. Our du is going to be equal to negative sine x dx. And then let's rewrite stuff. Okay. So as we did before, oh, hey, I'm missing a negative sign. Let's fix that, huh? Yeah. Throw a negative, throw another negative, double negatives. All right. So this negative, it stays negative. This negative with the sine x and the dx become du, right? It's right there. It's obvious. It's right there. Du. And then the cosine that's on the bottom becomes our u. U. And I'll rewrite it just like I did before, in case it's not obvious to you. It's 1 over u du. Antiderivative of 1 over u is the natural log of the absolute value of u, and then plus c. All right, so then the last thing to do, of course, is take out u and replace it with, in this case, cosine. So negative the natural log absolute value of cosine x plus c. Ta-da! All right, so what we just found is an antiderivative rule. So the antiderivative of tangent x dx is equal to negative the natural log of the absolute value of cosine x, boop, plus c. Right, this is not the only way that you see this. You can do a little bit of algebra, not calculus here. Well, algebra, I guess, combine it with some trigonometry to rewrite this a little bit. Because remember that tangent is always associated with secant, and what, this is not a secant, this is a cosine inside here. All right, but we can fix it. Watch this. Watch some magic happen. This negative, I'm going to make that a negative 1. That's being multiplied times the natural log of the absolute value of cosine x, boop, and then plus c. So I'm going to use a property of logarithms, which will allow me to take this power here. It's actually the coefficient, but it becomes the power, right? It's the power rule for integrals. So I'm going to bring it on the inside. That's equal to the natural log of absolute value of cosine x to the negative 1 power plus c. Negative 1 power means to take the reciprocal. So I have, oh, that's ugly. That's better. Okay, 1 over absolute value of cosine x, like so, plus c. And if I'm not mistaken, 1 over cosine is the same thing as secant. So this becomes the natural log of the absolute value of secant x plus c. And then you can see that we have, once again, the association between tangents and secants. Lovely. All right. Not something that you'll probably memorize, but if you ever needed it, here's the technique that you would use in order to get it. Here, let's come over to the slideshow so that we can summarize all of these new trig rules. So we have the one for sine. Antiderivative of sine is negative cosine u plus your c. Antiderivative of cosine is sine. All right. And tangent, we just discovered here. We have a negative the natural log of the absolute value of cosine. You could get rid of that negative, bring it on the inside, make that natural log of the absolute value of secant. Right? And here is the one for cotangent. It is the natural log of the absolute value of sine u plus c. And then we got a couple more, right? So we have sine, cosine, tangent, cotangent. We're also missing our secant. And so the secant's antiderivative is natural log of the absolute value of secant u plus tangent u plus c. I think that this is one in the homework exercises that you'll have to come up with. You'll have to prove that rule. And then, so what do you suppose, before I even put it up here, what do you suppose it is for cosecant? Could it be negative the natural log of the absolute value of cosecant u plus cotangent u plus c? So remember that our trick to remembering which ones get negatives is different for antiderivatives than it is for derivatives. For antiderivatives, it's your answer. If your answer is a cofunction, it's going to be negative. So look at this. Negative cosine, it's negative. Cosine right here, it's negative. This, oh, there's no cofunctions in here, it stays positive. Over here, there's no cofunctions. Even though I started with one, I didn't end with one, it's still positive. But down here, my cofunctions are inside my answer, I'm going to make it negative. And that's just a simple little trick to help you remember which ones of these are supposed to be positive versus which ones are negative.